Okay, this is the video for objective 2E and 2F. So, can we use backtracking to solve the following equation? Okay, so this equation says that, and you don't have to write all this down, it's just to lead into something here, that we take x, we subtract by 15, we multiply by -2, and then we add by 5 and get this answer. So what if we want to solve for x? How would we do this in the correct order? Well, that means we would subtract by 5, then divide by 2, and then last parentheses add by 15. So we can use backtracking to solve this equation. So let's look at a few examples here. Could we use backtracking to solve this equation? Well, in this case, we would subtract by 2 and then divide by 6. In this one, we start on the outside. We would divide by 2, then we would add 3, and then we would divide by 2 again. So what about these? Can we backtrack on these equations? Well, these are a little bit more challenging because something is not just happening to one t. We have t on both sides of the equation here, so we won't really know where to start. If we add 12, or if we subtract 12, let's say, so we're backtracking, it's going to cancel out here. We have 3t equals 5t, minus 6. 5t minus 6. Okay, but we no longer would be backtracking anymore because we can't just divide by this 3 because then we're going to have a bunch of fractions over here if we divide by 3. Yes, we would have t, but we haven't made anything simpler here. We still have t on the other side and we're trying to get the t by itself. Same with here. If we were to divide by 3, well, we could divide both sides by 3, and the 3 would cancel out here, and now we have 2t plus 4, and then this big long expression here, so even 2/3, 3t minus 1. But it hasn't really made anything simpler. It doesn't look like we've gotten very far. So let's look at some other strategies for those. Okay, so we're going to focus on 2F first, which is I can solve multi-step equations that have variables on both sides. So how are we going to solve this? Well, right here we can see that the top, well, let me write it like this. We have 3 t's on the top plus 12. And on the bottom part, we have 1, 2, 3, 4, 5 t's plus 6. And these actually equal each other. You can see it's the same length on this line, so they're equal to each other. Well, we can cross these out right away. They're just going to cancel canceling each other out. So we actually have 12 equal to 2t's plus 6. And we have it down to a 2-step equation and we could solve it. So let's look at a couple of others. Okay, so we have the pink part equal to the blue part. So let's go ahead and cross out what balances out already. These w's all balance out. So that leaves me on top with 3w plus 8. And the bottom part is 23. Now we can see that these both get to the same point on the line, so they are equal to each other. Now we just have a 2-step equation to solve. In this 2-step equation, once I have the w on one side, I can just use backtracking to solve it. So I'm going to minus 8 and minus 8. They cancel out over here, and I have left with 3w equals 15. Then I can divide by 3, and w does equal 5. And to make sure this is true, I can go ahead and plug it back in where the w was. I put the 5. Whoops, that's plus 8. There we go. So 3 times 5 is 15, plus 28. I keep doing it. Plus 8 equals 23, and 15 plus 8 does equal 23. So this is true. All right, here it is in just a different look. But these are going to cancel out. I'm going to get rid of an x over here. So to keep it balanced, I'm going to get rid of an x over here. I don't have another x to get rid of, but let's see if I can get rid of some of these triangles. I have 1, 2, 3, 4 triangles over here that represent 1. So I can go ahead and get rid of 1, 2, 3, 4 triangles over there. What I'm left with then is this x and 1, 2, 3, 4 ones. So this is x equals 4 to solve this equation. So this is how you would do it graphically, but we're not always going to have pictures like this. Let's see if we can do this with just the equation. In this case, I'm going to start off by combining my like terms, but when I go across the equal sign, in order to move across, I have to use the opposite. So if I take away 4w from here, I need to take away 4w from here. And this corresponds with this. Took away 4w's from the pink side, I take away 4w's from the blue side. Same thing's happening here. Gets rid of all of them over here, and here I'm left with 3w's, and I still have the 8. Equals 23. And you can see how that was the equation we ended up with here, there, and then we solved it. Here I want to combine my like terms. There's an x over here, and there's a 2x over there. This doesn't match up to the picture. Oh wait, sorry, this one does. We have our 2x's and the 1x. So once again, we're just getting rid of the x's. We're going to subtract an x here to get rid of it, and we're going to subtract an x here, and we're left with 1x on this side. So we'll just put x for 1x. Plus 4 equals 8. So now all we have to do is solve like this, subtract 4 from both sides, and x equals 4. Same answer we got here. All right, let's go ahead and try some just without pictures. So right away, I'm going to have to get the j's to the same side. And if I move the j to this side, then I would end up with 0 over here. So it's best to make sure you have something on both sides of the equation. You can certainly do it that way. It's just going to be a lot longer. So minus 5j minus 5j. We're going to get it to the other side, and we need to keep it balanced. So we do the same thing on both sides. Over here, they cancel out. And I'm left with 2j equals 10. I would then need to divide by 2, and j equals 5. If you plug this back in, it should work out the same. 7 times 5 is 35, and 5 times 5 is 25, plus 10 does equal 35. So I did come up with the correct answer here. All right, go ahead and pause the video and try to work this out for yourself, and then rejoin me when you're ready. So I'm going to get the ends to the same side. So pretty much I just want to get rid of the ends on one side so that I can solve this. So I'm going to take away the 2 ends here, so that way I've gotten rid of them from this side, and I'm left with 2 ends on that side. Equals 10. Now I've got it to a 2-step equation, so I'm just going to minus 7. This cancels out, and I'm left with, and then lastly, I'm going to divide by 2. And n equals 3 over 2. So let's make sure I did this correctly and put it back in the equation here. Okay, when I come over here, I'm going to put this over a 1. These are going to cross reduce. It goes into here 1 times and into here 2 times. So 2 times 3 is 6 plus 7. Here, if I put this over 1 and cross reduce, 2 goes into here once and goes into here once. 1 times 3 is 3 plus 10. Okay, 6 plus 7 is 13. And 3 plus 10 is also 13, so I did do this correctly. Okay, so now let's focus on objective 1E. I can solve multi-step equations that include distributing. So you'll notice that this just has a variable on one side. So it's just like the first problem I showed you here. It's a variable on one side, and we were able to use backtracking on this. We just undid everything. So when the variable's on the one side, you don't have to distribute. You can just go right from here and backtrack. It's a few more steps than our 2-step equations, but we can do it. So we're just going to minus 5. Minus 5, they cancel out here. I'm left with 2 times x plus 3 And on this side I have 20. And then this 2 is being multiplied with these parentheses, so I'm just going to divide by 2 to get rid of it. Divide by 2, they cancel out. I'll keep working over here, x plus 3 equals 10. And then I'm just going to minus 3 from both sides. Cancel out, and I have x equals 7. And if I want to double check, I'm going to put it back in here and make sure that it works out. So 7 plus 3 is 10, and then 10 times 2 is 20, and then 20 plus 5 does equal 25, so it would make this equation true. Okay, so what happens when I have variables on both sides? Well, I'm going to write this, but don't write this down. I'm going to put it in red here to show you that we're not going to do this. But this would be the incorrect way to do this. If I started out by dividing by 5, okay, it would cancel out here. Oops. It could go in there, and then I would have to distribute, but I still would have j's on both sides. So it's better to just go ahead and distribute and then combine those like terms. So when you have variables on both sides, go ahead and distribute first. So this is going to end up to be 5j minus 15 and 10j minus 20. Then you'll notice, once we've distributed, we have a problem similar to these. We just need to make sure that we get the j's on the same side. So if I want to get rid of, and I always start with the least amount, the side that's the least amount, just like we did in the drawings. Okay, we saw that we had 1 here, so we crossed it out. That means we could cross out 1 over here. We saw that we had 4 here, so we crossed out these 4 and then had what's left over. So get rid of what you have. So we have 5j's, so we can go ahead and get rid of all of them by subtracting 5j. Then over here, we'll find out what we have left over. These cancel out, and I end up with negative 15 equals 10j minus 5j is 5j minus 20. Now I'm down to a two-step equation. I can add 20 to both sides. They cancel out here, and I have negative 15 plus 20 is going to equal 5. Then I just need to divide both sides by 5. And my j equals 1. Okay, that is it. I will see you in class.